All right, so in this video, we're going to be doing triangle proofs, and they're called two-column proofs because you have two columns, okay? Statements are going to go on the left side of the column, and statements are like congruent statements. So like angle L is congruent to angle M, okay? We're going to learn about reasons in a second, but congruent statements are going to go on this side, and then this is just the justification, okay? So you'll have things called givens. You'll have the whole side, siding, side, that's an S. You'll have things like vertical angles over here. You'll have things you'll learn, okay? That's just a preview.
So let's first talk about these properties that we've seen before and some are new. So first, the reflexive property we've seen before, that's when AB equals AB. Same on both sides. That is when they're touching. So you've been making those marks all along, but the reason we can make the marks is because they're reflexive. Okay. Again, we've been working with vertical angles are congruent. I'm allowed to make those marks because vertical angles are congruent. Another justification you probably have not seen in a while are all right angles are congruent. So if I know I have right angles, then I know they are congruent. Number 4, alternate interior angles are going to be the most common ones we're working with because they're on the interior. And since we're dealing with shapes, we've got insides. So here are your parallel lines. Here is your transversal. So you can mark the angle closest to the parallel line. So boom, boom. If you had another set of parallel lines, for example, you would be able to mark the other angles. But based off that information, you're only allowed to mark that one angle. A segment bisector is going to cut a segment in half, so you can make a segment mark. So that's what they did here. So if this line was cutting in half TR, you could mark TQ and you could mark QR. Moving on, midpoint. We know midpoint is in the middle, which allows you to make two side marks. Okay. An angle bisector, again, we're allowed to mark an angle. So if you have DH is the angle bisector cutting in half BDF, then you're allowed to make those two marks over there to be congruent. Definition of perpendicular. Remember, perpendicular is an upside down T mark, and that is going to result in 90-degree angles. So if you know something is perpendicular, you're allowed to make those 90-degree angle marks. And then if something says it is a perpendicular and a bisector, you're allowed to make the 90-degree angle marks as well as the bisector. So for example, this line right here is perpendicular, so it made 90-degree angles, and then it was a bisector, so it also made it into two congruent parts. Okay. Those are the most common things we're going to be dealing with for making marks in proofs and triangles. But the hardest thing is you cannot assume anything unless it is given to you. So you cannot just make marks unless you know these vocabulary words or they give it to you. Okay? So make sure you've got the sheet of paper for reference, and then we're going to move on. So let's look at our first example. So I have these two triangles. We're going to start off pretty easy with I've got some fill in the blank categories going on. So given that angle Q is congruent to angle S, they've marked that for us. And then given angle TRS would be this 2, 1, is congruent to RTQ, the 2, 1. I want you to prove the two triangles are congruent. Okay. So first off, we're going to start with our givens. So they're going to go in the top left part. Let me find the other one. Here it is. So those are our two givens. Boom. Boom. Okay. So givens will always go first in our proof. Very similar to what we've done in the past. Another thing in the past, our proof part always goes bottom left, and that's going to be true here. So let me find this triangle thing. Okay. So look at that. We've done most of our proof. Okay. So now the middle part of your proof is going to be stuff that you have to mark. So I know that these two triangles are right beside each other, they're touching, so I'm allowed to mark TR. Okay. Now it is totally up to you with how you want to name it. You can say TRTR or you can say TRRT. In this case, they've done TRRT. So then you have to distinguish between, is that the reflexive property or is that the symmetric property? Okay, and so this is a symmetric property because it's flipped on both sides. Again, if you wanted to say TRTR and put reflexive, you would totally be correct. Okay, all right, so now that I have three pieces of information, I know an angle, and I know an angle, and I know a side, but I have to look at my picture to see actually what it is. So I'm going to look at one triangle. I'm going to look at this left triangle. So I have an angle, and then an angle, and then a side. Same thing over here, angle, angle, side. So those two triangles are congruent based off of angle, angle, and side. All right, so that's proofs of triangles. Okay, it's not too bad. It's not the worst proofs. In my opinion, the proofs that we did previously are much more trickier than these. So your givens will always go first. Triangles will always go bottom. And then one of those 5 properties you learned yesterday, side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg, those are going to go bottom right, always. And then in the middle will be the properties that you've seen on this page, basically. Okay? All right, so we're going to try the next one right now.
It wants us to prove that triangle KJL is congruent to triangle MNL. Okay, so notice I have a lot of statements down here. And what I need to do is I need to place them into this left column or this right column, okay? So, and a given is going to be this mark. So, for example, see how JL is marked and LN is marked. Okay, let me find JL and NL. Okay, here it is. So you're going to have to write it, but I'm going to drag and drop it. No. All right. So they told me in this picture that JL was congruent to LN. Okay, they gave that information to me, so it's called a given. Okay. They also gave you another given. They said KL was the same as LM or ML. So that was another given they gave us. So I'm going to write given. Okay. So notice your givens are always going to go at the top of the page. Okay. They have to give you something, whether it's in writing or whether it's in a picture. Okay. So now we know that we can make some angle marks. Okay. I know that those angles are congruent because they're vertical. Okay. So that would be KLJ is congruent to MLN. So that's going to go on the left side of the column. The reason I can mark them are because vertical angles are congruent. Okay. Now, the cool part is your very last proof, because I want to prove that these triangles are congruent. Whatever they want you to prove always goes in the bottom left. Okay. I'm trying to prove that those two angles are congruent. Now, the reasoning is the last one is going to be what we learned yesterday. So side, 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 side angle, side, etc. Okay, so I have proven that this triangle is congruent to this triangle because of these things. Okay, so notice you're going to have 3 kind of informations before you get to prove that those triangles are congruent. Okay, so we're going to do a little bit of drag and drop for the next couple times, but you are going to have to eventually come up with these on your own. Okay, all right, but let's move on. These two on your own. So try this one and then try this one and press pause, and then we will go over the answers. All right, the other example, a little bit trickier. So it gave me JK and NK were congruent given, and it gave me A as the midpoint of JN given. Okay, so you kind of had to make 2 marks right here and here. Okay, I started off with this AK mark because that was either reflexive or symmetric. And if you say AK and A or KA and AK, that would be the symmetric property. Again, if you named it KA was congruent to KA, that would be reflexive property. Now, we've never done midpoints before on proofs, but we do know that if A is the midpoint, then I know that this piece is the same as this piece. So what I did was I said JA was the same as AN, because that's the definition of a midpoint. Okay? So lastly, I proved that those two triangles were congruent by side, side, and side. Okay? So hopefully this is getting a little bit better. Next one, a little bit trickier because they brought back parallel lines. Okay? Remember, if you've got parallel lines, you can have alternate interior angles. Okay? So I wrote my two givens first. I made this mark because of the reflexive property, or symmetric, depending on what you name it. And then to do angle, side angle, you needed another angle. So again, you needed SRQ to be the same as PQR. Okay? And that is true because alternate interior angles are congruent. And then you could have the triangles are congruent by angle, side angle. Okay? All right, so let's move on to when we've got some complete blank proofs. Okay? So we've got two examples of these. I'm going to try the first one and you could try the second one on your own. Okay? So first off, my givens are going to go on the left side. So I know that NER is going to be congruent to angle NVR, and that is given. So let me make that mark. NER, which is already marked, NVR. Okay, so I'm good. My second given is that RN is going to bisect angle ERV, and that is given. Okay, so if RN is bisecting an angle, I know that this angle is going to be the same as that angle. Okay, so what I can now say is what I just marked. So I marked that ERN, that is going to be congruent to VRN. Okay, so again, if you've got a bisector, it's going to split the angle in half. So I named it ERN and then VRN. Okay, why can I say that? That's the definition of a bisector. Okay, all right, so I need one more mark, and I know that this mark right here, I'm going to say RN is congruent to RN. Okay, again, you could say NR, but that's going to be the reflexive property. Okay, so now that I've got three marks, I know that that is going to be angle, angle, side. And I know this proof right down here is going to go here. So ENR is congruent to triangle VNR. Okay, so a couple things. Your givens are always going to be at the middle. Could I flip-flop these? Of course. Okay, once you do the givens, you can do it any order you wanted to. So if y'all saw the reflexive property and you wanted to put it first, you're more than welcome to. Okay, all right, so we're going to let you be free on your own on this one. Notice I've given you 5 boxes and you are going to have to fill all of them, okay? So why don't you try this one on your own? Press pause and then we will go over it. That's pretty tricky, not going to lie. So when TR and MN are bisecting each other, that means if this line is going to cut in half this piece and this piece. So I know that this part is equal to this part, and then this line right here is going to cut apart this half and this half. Okay, so if you've got a line bisecting another line, you're going to get basically like a midpoint. Okay, so that was a given, and then you had to kind of make these marks and then name them. So I started off with TP, and I said that it was the same as RP. And the reason I can do that is that's what the definition of a bisector is. Okay, same thing up here, NP and MP are going to be congruent because that's the definition of a bisector. Lastly, I've got some vertical angles. So I named it MPT, and then you're going to have to start MPR to name those two vertical angles. Again, you can't say angle P because you don't know which one you're talking about. Okay, so the reasoning was vertical angles are congruent, and then lastly I have side angle side. So I wrote down this proof down here in the bottom left that I have proof that those two triangles are congruent.
All right, so to wrap up proofs, I'm going to give you guys 2 more problems to try on your own. This one is a little bit easier because it's kind of fill in the blank. So try this one and then try this next one all on your own, completely blank proof, but you guys can do it, all right? Then we'll go over answers and be done. So try these, press pause, and we'll go over the answers. All right, so some answers, sorry, COVID, answers to this problem. So I wrote down my two givens here and here, and I wrote given, given. Now I had to make some marks. I first marked angle 1 was congruent to angle 2, and then now it says CD is bisecting angle ACB. So ACB is over here. So if CD is cutting it in half, I know that each part is going to be congruent. So I made those marks and then I had to write those marks. So I named it angle ACD was congruent to BCD. Again, you could have these orders flip-flopped. Reflexive property would be this middle, so CD, CD, or DC, DC, up to you. And then proof triangle always goes bottom left. And then so you need to make the marks on your picture to figure out it was angle, side, angle for them being congruent. Okay. All right, moving on. Our last one. So I had two givens, wrote them first and wrote them second. You could have these orders here flip-flopped, but you did have to have the proof at the bottom. So I went ahead and talked about my vertical angles first. So I said ABD, then CBE. Again, you could have the orders flip-flopped, but I know they're congruent because vertical angles are congruent. You could have put vertical angle theorem either way there. Now the next one might have been a little bit tricky. So you have AC bisecting DE. So AC cuts in half DE, so you have to make the marks along the line DE. You don't make the lines along the mark AC because AC is like the knife that is cutting in half DE. So you get a mark here and then you get a mark here. Okay, so it's always what happens last is what is going to get the marks. Okay, so that's why it was angle, angle, side, and not angle, side, angle. All right. All right, so that is proofs of congruent triangles. Again, givens always go first, triangles go bottom left, one of your 5 theorems goes bottom right, and in the middle, you've got your marks to make. All right, good luck practicing. Let me know if you have any questions.